Welcome to Petroleum Software Online Training. I am Renato Smahuyu, your course instructor. From last lecture, we saw about how to import well data, and there was different kind of data which we call them as well data, like well header, well deviation, and well logs. But we imported well header and well deviation. So welcome once again in our online class, and in this lecture number 3, we are going to see about how to import well logs and how to import well tops. Also, we are going to see how to do well correlation and adding other wells which are not present in the well logs. So also we are going to see how to make surface and structure modeling.
Now let's begin with importing well logs and well tops.
The first step in importing well logs, you need to know there is a format of your well logs. So there are different kind of formats you can use them to import into a well logs. But the first structure, the first format we are going to show you is Petrel well logs, which is in the format of
LAS 3.0, LAS, and also well logs. They may exist into the format of ASC2. So according to the data we're going to use the data which are in the format of well logs LAS. So this will be the format which we're going to use into our data format. So now let's see how you can import the well logs which are in this format. First, you need to go to the wells, and then you need to right click, and then just go down to the import selection, then select well logs, and then you can select all of them from the first one to the last one. You click the first one, then shift, then click to the last one. So the format here is supposed to be well logs ASC2, like this one. Then click OK. So once you do this, you have to make sure that the file name is supposed to be equal to the well trace. So for example, here we have the file name is L1727. So the well trace is supposed to be the same. If they are not the same, you have to come here and then you select the exact name which is supposed to correlate to be equal to the file name. So for us, all of them, they are the same. So you can just leave them as the way it is. So make sure the file name is the same to the well trace. Click OK. And then once you come here, you have to make sure that from the data, for example, here you have been given an example of that well logs. So here you have different depth. You have depth, you have logs. There is SPGR, CR, AS, RT, and then you have to go to the last. You have a lot of logs. So what you have to do, if you are importing the well logs in this format, you need to go just direct here to specify the logs to be loaded here. So in the second thing, or the first thing, you need to go here. You have to make sure that the columns, you have many columns. First column. So the first column consists the data. So the first column is MD. It comprises of depth data, so it's true. So here you have to put it 1. If the depth is in the first column, so the second column comprises of SP. So once you come here, for example, you may have that there is nothing here. So what you need to do, you need to come in this place and add the logs. So once you click here, you add the logs according to the number of logs, according to the number of columns you have. So here we find there is log name, there is column, there is property templates, and there is global well log. So what you have to do, you have to make sure that the log name is supposed to be the same like the column name. For example, SP is on the second column. So here you have to write it as SP. SP is supposed to be on the second column, like the same is. So on the third column there is GR, so the same like this. The fourth one is CAL. It's here, so you have to write CAL, the same applied, and it's supposed to be on the fourth column. So the same applied you have to do. You have to write or to enter all the logs, the log names. For example, like here. After that, you have to enter all the columns. We have 17 columns, so we don't have to use this one. So I have to delete them. Just click here, then delete. So after that, we need to come again here into the after writing the log name. Now we have to come to the property template, where you will choose the same name as what you have put it here. So if, for example, the second column, or in the first row, like SP, this one is SP, so you have to find that SP is returners from this property template. Like you have to scroll down and find returners right here. And once it is GR, it is gamma ray, so you have to look and to find it from here. So the same applies to the all wells. If you find that there is, maybe you are not sure of the log name which was written here, so you can just specify it as general. Like here you have to specify it as general. But for the logs which you know their names, like policies, you just come to the proper templates. Make sure you just put the right templates from the list within here. So after that, just click OK. So till there you'll be ready. You have already imported the well logs. So if you want to visualize or to see them, just go to Window and then you go down to the well section window here, and then come to this plus, open all the logs, you find them here. But once you click these logs, you not display anything here. So the first thing you need to do, you just go down to the well name. For example, I want to find out the logs of this well. So once I put a tick here, and then I will go back, then click SP. So you'll find that all the logs are here. So if I click GR, I find all the logs are here. So apart from that, you can also create a car, or you can just call them here. Then you can put some color on them so that it will be easier for you to read. So it's like this. So if, for example, I want to find out about the velocity of this log, it's here. So just click, and then you find out, you just get a log in this curve. So the same applied if you want to see the logs for this well. Just come in here and then just click like this. So from there you'll be able to categorize all the logs of your wells. So now we have imported well logs and have seen how you can check or you can identify the logs in every well. So I've just put 2 wells here. So if you want to remove those wells, just click this like this. So once you go back, then just open another well, this one, then just click them. So here you find this is cost log, this is gamma rays log, this is SP log. So that's very simple. We just identify every kind of log according to the well. So now let's see how to import well tops. So we have finished to import well logs. Now let's import well tops. Well tops also, we can import well tops, but the well tops are also imported into this format. So well tops must be in this format, like Petrel well tops ASC2. So now let's see how you can import well tops. First, you need to open the 3D window like here, and then you'll come just here. Don't go to the wells and right click when you want to import well tops. So you just come in this place, right click, import, and then you need to find out about well tops. So we said well tops, it was that data format. So Petrel well tops, it's here. So just click well tops. After that, go back, well tops, it's here. Click. Then once you open well tops, you find that you have your data here. These are different data. So the well tops are defined. The data of well tops are given into different values. So you have X value, you have Y value, which shows the position of the well, and also there is a Z value, which is the negative, which is negative, and the negative, it means the value of Z is the depth of the well. So from the top to the ground. So this is the depth value. Also you have a surface. So there are different surfaces. So once during drilling, this surface is obtained during drilling. So we can say well top is just a data obtained during drilling. So once they reach a certain log surface, maybe of different texture or of different type. So every layer, maybe I can just say every layer during drilling a well, every new layer reached, that is what like is named as a top. So that is a well top. And mostly this data is used to use well tops to create surface. So maybe you may find that after 10 kilometers and the ground, you find that maybe there is a certain texture or a certain layer, the log, maybe in well number A, and then when you go to well number B, you find that maybe at a certain distance, a certain depth, you find the same structure which was obtained from the first well. So those kind of surface or layer obtained during drilling, that's what we call well tops. So usually if you have this data, it will help you to create surface rate, and then we're going to see how to create surface. So also we have undefined value. Which is -999. So, and this was obtained maybe from our data. So in our first name, our first header, we have header in our data. So that's why we said number of header, we have just one header. So what we have to do here is just exactly the same like how we've been doing importing well header, but here you have to specify like first column comprise of X value, so just say X value. The second one comprise of Y value. The third comprise of Z value. The fourth we have surface. So for the fourth here we have surface, and then the fifth we have wells. Like here we have well names. So we have well name. At each well there is this. At each well, for example, at this well L1727, the surface is 135 top, and this kind of surface was obtained at the depth of 144. But for the well number LJ1926, the same surface, which was the same surface like this one, for this well was obtained at the depth of 166.15, 166.55. So the same applied to this well name. For this well also, this surface was obtained at this depth. So like I've said, well tops just define a certain surface or a certain layer then at each well. So once we have specified all this data, and then don't forget to specify the depth, but it's not obvious the same, but you just specify all of them. After that, okay, so file contain both XYZ well name. Don't worry, because we have been given Z value, so there was no need of having measured depths. Okay, that's good. Okay, then this data will be obtained from here. So once we put them, we just find them like this. So these are the well tops which we are given to each well. So each well has its own well tops. So what you need to do, you can just make sure that you change maybe the shape of this of the tops. So for example, just come to the well tops, so it grid setting, and then after opening the setting, you can change the size of the shape. Spherical shape. I usually like to put 8, for example. Put 8, we just set them like this. So we have well tops at each of the well. At each of the well. So after this step, now you'll be ready having this well top in each well. Just to show an example, these are the letters which shows the well tops layered line. We have X, Y, and Z here. We have well tops point, so are given names as horizon, its surface, and there is well name. So this is just an example to show you different variety kind of data which shows the well tops. So coming from here, you can see, for example, here we have, for example, we have well different. There is well this well C. We have all other wells here. So you have a well top at D. This is a well top D in this well. So there is another well top also in another well here. Well top D. So we have another well top D at this point. So if you this data from this here, from this well, this well, this well, this is what we call a well top. So it gives the surface of the well. So, but for example, for them in a straight line, let's look at this well top number C, well top C. So here you have well top C at this depth. Maybe, for example, here it is 20. We have 20. but here it is 40 meter. And here well top in this well, maybe it is 30 centimeter depth. So you may find that the same layer in this well was obtained at this depth, but the same layer in this well was obtained at this depth. So this is what we call a well tops. So once you have this kind of data, when you want to create surface, when you want to create a model, it will show you the shape, the exact shape of the geological model in the ground. So this is one of the very important data you need to have during creating a geological model. So that's why I've just shown you the well tops, the way it can be used to create a model. So you have, for example, here you have point A, which is the well top in this well. In this well also we have point A, which is this well. Also we have point A in this well at this point. So this is what we call a well top. So we're going to see later how to create a surface from using this well top.
So now let's see how to do well correlation and well log. So as we have seen, like we have already imported well logs and well tops, and we said well tops, they just show the different layer according to the log which was obtained during drilling. So, and the logs are the information which were given from the logs using a certain methods or electrical methods, like taking pictures or taking some value like resistance, spontaneous, gamma ray from the log, from the reservoir log. So we can now correlate our well. We can do well correlation by putting on first, like the way I'm going to show you here, is when you want to do well correlation, you need to go to the well section window and then make sure all your wells are on. Example, have all these wells, you need to put them on, all of them. So once we click on well top here, you just see there is some lines which are drawn from the first well to the last well. So you can even try to put on some of the information, maybe the SP, GR information, and then color them. I can show you, just put the color of them. So once you have all of them like this, you just have different well logs. So just minimize this, open the well log, attributes, others. So here you may find out, for example,
they put maybe top, a top surface. So a top surface, we find that in this well it have passed through maybe the distance this one at 150, but at the second well this surface was just below, information was just given below at almost 160. So this is like well correlation. So automatically, since we have already this data of well, we have this data of well tops, so it will just show us different how do this value relative like were obtained. So these are just different surface. So this is the way of how you can do well correlation. So in the another thing which is very important, like during this well correlation, maybe you need to have some lithological information, lithology information of the reservoir log. Such of them are like the faces, sometimes lithology data you need to have all of them. So, but according to our well logs, we don't have that kind of information. So later on, I'll show you how to calculate, because since we have been given SP and GR, but we don't have those information, those kind of log information like lithology or faces. We don't have those kind of data. We can calculate them using SP and GR. So I will show you how to calculate them. That will be later. But for this lecture, I'm just trying to show you how to do well correlation. It's just very simple like this, and then I will show you later again after calculating those kind of log information like lithology of the log of this reservoir. So now that's just how you can do well. So, and now I want to show you how you can add well log using a calculator. As we know that during being given this data of well logs, we know that the well log can be delivered. You can derive, or you can have another kind of data according to the presented data. So for example, we need to know the lithology of the log, the lithology of the reservoir log. So how? But according to the data we have imported here, there is no lithology data. So but since we don't have lithology data, but we still have gamma ray and SP ray, we can use those data. We can derive the lithology data from those data. So how you can derive, like you can calculate the lithology data through using those kind of data like SP and lithology data. We're going to see them later after this slide. So the delivered log is a very easy method to measure log data on the single or multiple well without physical etching them. So first, what we need to do, how to create a continuous log, or how to create discrete value. So first, before starting to calculate or to deliver those to derive the logs from the present log, first we need to know the different kind of data we need to have. So there is something called discrete data, and we have something called continuous data. So for discrete data, these are data like lithology data, which are given in number 1 to the integers, like there is no decimal place, the exact number. For discrete value or discrete data, I can give you an example, like you can say that maybe if in a class you have 10 students, so the value of 10 students, like that is what we call discrete data or discrete value. So you can't say that in a class there are 10 and a half students, so there is no any person who is a half. So you just give a value which is exactly, it's an integer. like 1, 2, 3, or there is 10 or 20 students or 17 students. So exact number. So in petroleum or when doing reservoir modeling, discrete data at the data lithology log, which may give a data in a discrete value like lithology data. So once a log is a sandstone, or maybe it's a fine sandstone, it will just, according to geological data, so lithology data, we classify lithology data like it's obtained in discrete data. We call them as discrete data. So for continuous data, these are data like porosity or permeability. For them, you can just get any kind of value. For example, for porosity, you can just get porosity like in its value, maybe it's 0.15 or 0.2, 0.18. So for them, those kind of data we call them continuous data. So even for well logs, the data are classified mostly into two kind of data. We have discrete data and we have continuous data. So once you want to calculate or to derive another logs, you need first to identify what kind of data are you going to derive. For example, for us now, I want to calculate the lithological data. So how I'm going to calculate the lithological data? Here is a formula. First of all, the first formula we need to derive the lithology data. Maybe we want to deliver lithology data from SP, for spontaneous data. So first we need to calculate the alpha, and the alpha for SP is derived by using this formula. So I'm going to show you practically how you can put this kind of data into a calculator and get the alpha. So after getting this alpha, you now move to lithology calculation. So lithology calculation, you use the following formula. But first, in order to start calculating the lithology data, you need to identify like this lithology data is available. It's on which data, like is it discrete or is it continuous. So after that, you just go back like how to create continuous or derived log, or how to create discrete value. So now let's start practically to see how you can calculate the lithological data.